Hi, I'm Bill Kleitz, Professor of Electrical Engineering Technology at the State University of New York's Tompkins Cortland campus. I'm also the author of several electronics textbooks with Prentice Hall. If you want more information about me or my textbooks, you can Google me at Prentice Hall or at Amazon.com. The podcast that you're going to be watching is from the 9th edition of my digital electronics textbook. I hope you find it useful.
Hi, this is Professor Kleitz, and before we start with Chapter 1, we want to look at the preface so that we can study the features of the textbook so that we can make the best use of the resources. The 9th edition of Digital Electronics, A Practical Approach with VHDL, covers the fundamentals of digital circuitry for mainly engineering and technology students. The digital circuits that we'll be looking at are first introduced using the general theory of digital electronics and then usually are implemented using the 7400 series ICs. The newest field in digital electronics deals with field programmable gate arrays, so that's how each of the chapters will progress. We'll be programming the digital logic using a language called VHDL, and we can also enter our logic designs using a schematic capture method. Any students wishing to skip the VHDL and the FPGAs can do so just by, when you look in the margins of each page, you'll see the VHDL section in the margin. If you skip that, it's not going to change the continuity of the remainder of the text, because you can follow through all the other digital designs using the regular 7400 series if that's your choice. Basically, the text is divided into two halves. The first half, chapter 1 through 8, cover the basic digital logic and combinational logic. And then as you move into chapters 9 through 18, you'll see that we'll switch over to sequential logic and digital systems. It's not really mandatory, but it's really helpful if students using this text have an understanding of, or at least concurrently enrolled in, a basic electricity class. I put together an Appendix F that covers all the basic electricity you'll need to get through this textbook. So if you don't have the basic elect background, spend some time in Appendix F before you start the text. Throughout the textbook, you'll find margin annotation icons. The first icon is for common misconception. After teaching this course for so many years, I've found a lot of stumbling blocks that the students typically have. So I point those out in the margins. You read these as you go along. Also, team discussions. These are good for any kind of cooperative learning where students will get together and discuss a particular principle, and that'll be indicated by the letter D. And helpful hints. These are just hints that I've come to use for all my classes through the years. Read those. It gives you a good insight into a particular subject matter. Also, anytime we're covering any digital logic that typically you'll find inside your PC, I'll have this PC type annotation in the margin, so check those out too. Okay, so the basic problem sets are set up as 3 different choices. You'll have a design type problem. It'll have the letter D in front of it, where I'm going to ask you to design a circuit to perform a specific function. There's also the troubleshooting type problems, where I introduce some errors in a circuit and I ask you to deal with the malfunction and try to determine what it is that's wrong. And then the more challenging ones basically will ask you to solve a problem that's a little bit beyond the typical introductory type lesson. Now, Multisim is a software simulation tool that I highly recommend you purchase. You can purchase that online. It's a National Instruments product. And throughout the textbook, I have examples within the chapter, and at the end of every chapter, I'll have several Multisim problems. So the files for these problems are included on the companion website. You go to the companion website, you download those to your PC. I recommend that you download all the examples and problems and put them somewhere on a flash drive so you just have quick access to them. So again, throughout each of the chapter, I'll give you several examples, and I'll be talking to you, and I'll work through these examples using podcasts. And at the end, check out the problem sets. And a lot of students like to do some of these problems and examples at home before you come into lab to actually build the circuit up. You can actually perform a simulation so that you have a second way to double check your work. You'll also find schematic interpretation problems. What I've found over the years is students have often come back to me and say, geez, we understand the fundamentals and pieces here and there, but when we get on the job the first day, they throw this huge schematic at us and we have to deal with really complex circuits. So what I've done throughout the textbook, starting right away with chapter 1, is dig into some real world schematic diagrams, which you'll find in Appendix G. And what I'll ask you is, starting out with some real basic identification and so on of the schematic, working right up through to troubleshooting and design using the real world large scale schematics. And you'll find these problems at the end of each chapter. So also you'll find several FPGA, first of all, the examples in each chapter. You'll find several examples of FPGA problems solved using the schematic capture method as well as the VHDL method. And at the end of each chapter there'll be several FPGA problems for you to solve using the free Altera Quartus software. You can also go the next step and actually program the FPGA on a educational board if you have one. So throughout the text you'll find that we'll start out by designing digital logic using the 7400 series fixed function type logic, and then move into either the schematic capture method of design, graphic design, or the VHDL programming method. And our VHDL programs are well annotated. In some cases you'll be asked to write original programs, and other times you'll be asked to modify existing programs. All of the VHDL programs that I've got in the textbook are also available up on the companion website for you to download. And of course, the laboratory experimentation is a very important component of any digital electronics class. So any of the circuits that you see in the book, any of the figures, can be reproduced in lab using either the fixed function type 7400 series chips or using the Altera Quartus software to implement using a graphic design or the VHDL programming language. Now, once you've built the circuit, and also you can use multisim, of course. So a lot of times you'll design a circuit using multisim at home, then you'll come in, you could build it up using the 7400 series integrated circuits, and then you could actually use Quartus to design the circuit and download it to a programming board. So the Altera Quartus 2 software that we'll be using is a free download from Altera Corporation. They're one of the leaders in FPGA programming and software development. It's recommended that you join the Altera University program by going to altera.com. It ensures that you'll be kept up to date with the latest products. And they also really want to help out universities that want to use their software and hardware. So I highly recommend you join this program. Now, the FPGA programming board that we'll be using throughout the book is this DE2 Development and Education Board, manufactured and sold by Altera Corporation. There's several other DE type boards, but this has an actual FPGA on it. So after you've done your simulation and your design and simulation, then you could actually download to the actual FPGA and demonstrate the operation to your instructor. So that concludes a brief introduction to the preface. I really highly recommend that you go back and read the preface. There's a whole lot of other information that's in there. And if you need a little quick review on basic electricity, check out Appendix F. Okay, so next we'll start by jumping right into section 1-1.